In the spring of 1987, a forestry surveyor named Kenji Arata was mapping vegetation inside a volcanic exclusion zone on the slopes of Mount Wakahara when he found 3 trees that had no business surviving there. They stood on a narrow basalt shelf, ash-blackened rock on every side, in a zone that had been sealed off from all human entry since an eruption 4 decades earlier. The trees were cherry, but not a variety anyone recognized. Pale pink blossoms, unusually thick bark, and root systems that had somehow anchored into cracked volcanic stone with almost no soil at all. Arata almost didn't stop to look. His permit only covered a 2-hour window before the monitoring station required him back below the ash line, and the shelf sat at an angle steep enough that reaching it meant leaving the marked survey path. He photographed the trees, took what samples he could reach without climbing higher, and filed his report as an anomaly for someone else to follow up on. It seemed, at first, like a stroke of luck. A wild cherry species, untouched by logging, grafting, or cultivation, had survived in near-total isolation. But when botanists examined the trees more closely, they found something that made preservation far harder than anyone expected. All 3 trees were producing blossoms, but none were producing viable seed. Arata's samples reached Dr. Michiko Sato, a botanist at Kyoto University, who specialized in wild prunus species and had spent much of the previous decade cataloging mountain cherry variants across central Japan. In her first report, filed later that year, Sato tentatively classified the trees as a variant of Prunus jamasakura, the mountain cherry native to the region. It was the closest match available. But the classification came with a caveat she flagged from the start. She had only flowering branches to examine, no fruiting material, and no way to confirm the tree's full reproductive cycle from blossoms alone. The gap in the record wasn't filled for years. Access to the exclusion zone required government clearance, volcanic monitoring had priority over botanical research, and researchers were only permitted brief supervised visits, usually no more than 3 or 4 a year. Sato herself made the trip only twice in the following decade. A rival classification surfaced in 1994, when a visiting researcher named Tomoya Sekin, working from Arata's original pressed specimens rather than a site visit of his own, argued the trees were simply an unremarkable regional form of Prunus jamasakura, not worth a distinct designation at all. Sato disagreed publicly. A pressed herbarium sheet, she argued, couldn't show bark thickness, root structure adapted to bare rock, or the specific timing of bud break that she'd observed differed from every other jamasakura population on record. The dispute went unresolved for a decade, mostly because resolving it required fruiting material that, as far as anyone knew, didn't exist. It wasn't until a full taxonomic reassessment in 2004, once viable seed finally existed to examine, that the trees were confirmed as a distinct, previously undocumented subspecies, one that had likely diverged in isolation for centuries, sealed off first by the mountain's remoteness, and later by the exclusion order itself. Sekin's classification was formally withdrawn the same year. By then, the central problem hadn't gone away. It had only become clearer. The trees required a specific pollinator to set fruit, a native solitary bee species, long documented in regional botanical records as a mountain cherry specialist. But that bee had effectively disappeared from mainland Japan decades earlier, a casualty of agricultural pesticide use across the surrounding valleys during the 1960s and 70s, well before the volcanic exclusion order had even been put in place. Without it, self-pollination between the 3 isolated trees produced blossoms every spring and almost nothing else. Sato's early field notes put it plainly. The trees flower faithfully, they do not fruit. The irony wasn't lost on her. The same volcanic isolation that had protected the trees from logging and development had also cut them off, permanently, from the one insect they depended on to reproduce. Whatever had spared them from a chainsaw had also quietly sealed their reproductive fate. Botanical rarity registries that later cataloged the grove listed it among the smallest known wild populations of any cherry variant on Earth. 3 individuals, 1 confirmed lineage, and, as of the mid-1990s, No natural or artificial path. Sato's first attempts to solve the problem followed a familiar route: cuttings. Grafting hardwood cuttings from each of the 3 trees onto rootstock in a controlled nursery outside Kyoto. It worked, technically. The cuttings took root, grew, and by the early 1990s stood as genetically identical clones of the original wild trees. But a nursery clone wasn't a wild population, and cloning did nothing to solve the reproduction problem at its source. The volcanic grove itself was still frozen at 3 trees. No seed, no next generation, no matter how many clones grew in pots 200 kilometers away. It was a graduate student working under Sato, Haruto Ide, who eventually took the problem in a different direction. Ide's background wasn't in cherry propagation. His research focus was pollinator ecology, specifically the decline of solitary bee species in post-agricultural landscapes across central Japan. He'd been brought onto the project to study why the bee had vanished, not to fix the tree. But the more time he spent at the site, cataloging what pollinators remained in the surrounding forest, the more the 2 problems looked like one and the same. Ide's first approach wasn't hand pollination. It was reintroduction. Working with a small surviving population of the same bee species, discovered in an unrelated nature reserve nearly 200 kilometers away, he attempted, in 1992, to establish a satellite colony near the grove, transporting nesting females in ventilated containers and releasing them at the start of the blossom window. The colony survived the first season but failed to overwinter, likely unable to tolerate the volcanic ground temperatures at that elevation. A second attempt in 1994, using a modified insulated nesting box designed with an entomologist from Hokkaido University, lasted slightly longer, but collapsed the following spring when a minor eruption event closed the zone to all access for 4 months, cutting off monitoring at the exact moment the colony needed it most. But collapsed the following spring when a minor eruption event closed the zone to all access for 4 months, monitoring at the exact moment the colony needed it most. 2 failed reintroductions in. Funding for the bee approach was quietly deprioritized. It was only after those failures that I'd turned to a more direct, more labor-intensive method: manual cross-pollination between the 3 wild trees, using a soft brush technique adapted from commercial orchard cherry breeding. Timed to a narrow 7 to 10 day blossom window each spring, requiring him to be physically present on the mountain, inside the exclusion zone. During one of the only stretches of the year access was reliably granted. The first 2 seasons produced nothing viable. In the 3rd season, in 1996, one of the 3 trees set fruit for the first time in its documented history: small dark red drupes, each containing a single viable seed. It was the first seed the grove had produced in at least 50 years, and quite possibly the first in its entire recorded existence. Growing that seed into a mature tree took time the team hadn't fully accounted for. Cherry seedlings from wild prunus lines typically need 4 to 6 years before they flower on their own, and the first several seasons of growth happened entirely in a supervised nursery, isolated from the volcanic soil and mineral conditions that had shaped the parent tree's unusual hardiness. There was no guarantee the seedling would even retain the traits that had let its parents survive on bare rock in the first place. In 2003, the first seedling grown from that hand-pollinated seed flowered independently for the first time, with no manual intervention. Researchers gave it an informal name inside the project: Ichi, meaning first. Ichi's flowering marked the point where the lineage stopped, depending on a person with a paintbrush every spring, and had, at least on paper, gained the capacity to reproduce on its own. But one flowering seedling in a nursery outside Kyoto wasn't the same as a wild population back on the mountain, and everyone working on the project knew it. Returning trees to the exclusion zone raised a different set of problems entirely. The area remained under active volcanic monitoring restrictions, and introducing nursery-grown seedlings risked bringing in soil pathogens the isolated grove had never been exposed to in its centuries of isolation. Any reintroduction had to be planned with the same caution used for the original discovery, if not more, since a mistake here could affect not just the cherry subspecies, but the handful of other rare plants documented growing in cracks along the same shelf. The shelf itself, researchers eventually realized, was worth protecting for more than just the 3 cherry trees growing on it. A 2008 botanical survey of the same rock face cataloged 11 other plant species clinging to cracks and ledges nearby, at least 2 of which hadn't been documented anywhere else on the mountain. None faced the same reproductive crisis as the cherry trees. Most were self-fertile, wind-pollinated species that had simply never needed an insect partner to survive. But their presence changed how the team thought about the shelf. It wasn't an isolated anomaly holding on to 3 unlikely trees. It was a small, intact fragment of what the mountain's vegetation may have looked like across a much wider area, before grazing, logging, and decades of agricultural expansion reshaped everything below the exclusion line. The cherry trees had simply been the most visible piece of something larger that had quietly persisted, unnoticed, for far longer than anyone realized. That planning eventually brought in a party the botanist hadn't expected. The caretakers of a small mountainside shrine at the base of Wakahara, whose families had maintained a shrine forest boundary near the exclusion zone for generations, long before the eruption that sealed it. The shrine's oral tradition held that a stand of cherry trees higher on the mountain were sacred and were not to be disturbed under any circumstance, a belief that, unknowingly, had helped keep the area free of foot traffic and informal logging, long before the volcanic exclusion order made that protection official and legally binding. The shrine's head caretaker, a woman named Yumiko Hase, had heard fragments of the story for years from her grandmother, without ever knowing the trees in question had a name in a university database 200 kilometers away. When Sato's team first approached the shrine to request access through its grounds for equipment transport, Hase's first question wasn't about permits. It was whether the researchers intended to remove anything from the mountain permanently. Told no, that the goal was to eventually add trees back, not take any away. She agreed to the access on one condition: any research conducted on land adjacent to the shrine grounds would proceed only with the shrine's involvement and full sharing of findings, not after the fact, but as the work happened. It was an arrangement neither side treated as a formality. Today, the shrine community and the university's botanical program jointly oversee monitoring visits to the site, and new researchers joining the project are, by agreement, introduced to Hase's family before they're introduced to the trees. As of the most recent survey, the original 3 wild trees are still standing on the same basalt shelf where Arata found them in 1987. They remain the only confirmed wild individuals of the subspecies anywhere on Earth. In cultivation, the picture looks different. Grafted clones and Ichi's own descendants now grow in a research nursery outside Kyoto, in a university botanical collection, and in a small planting near the shrine grounds at the base of the mountain, tended in partnership with Hase's family. A handful of second-generation seedlings, grown from Ichi's own independent flowering, rather than from hand pollination of the original wild trees, reached flowering age themselves in the early 2010s, the first point in the project's history where the lineage was reproducing 2 generations removed from any direct human intervention at all. None of those cultivated trees changed the subspecies' official conservation status. Under the criteria used for wild population counts, that only shifts once a self-sustaining population exists back on the mountain itself, not in pots and nursery rows elsewhere, however numerous those may become. There is reason for something more than caution, though. The subspecies' unusual tolerance for thin volcanic soil and its resistance to a fungal blight common in cultivated cherry varieties have both been documented in the descendants grown from that first seed, despite every living tree tracing back to a single fruiting event in 1996. Researchers studying the blight resistance in particular have suggested it may prove useful well beyond this one subspecies in breeding programs for cultivated cherry varieties elsewhere in the country. Ide, now leading the reintroduction phase himself, more than 2 decades after he first arrived on the mountain to study a missing bee, has said the goal was never the nursery. It was always the mountain. Every seedling that flowers on its own is 1 step away from 3 trees on a rock shelf, and one step toward a wild population in full, not clones in a collection, but trees rooted back in the ash and stone where the species has always belonged. The reintroduction plan currently under review would return the first nursery-grown seedlings to a site on the shelf itself sometime in the next several years, pending final clearance from volcanic monitoring authorities and a soil pathogen screening process modeled closely on protocols developed for similarly isolated island ecosystems elsewhere in the Pacific. If it succeeds, it will mark the first time in the subspecies' documented history that a tree has grown on that mountain without either total isolation or direct human intervention keeping it alive. Simply a wild cherry tree, growing wild, the way its three ancestors did for however many centuries came before Arata ever climbed up to see them. Whether that happens on the first attempt or the fifth, the team involved has learned over nearly 4 decades now not to treat any timeline on this mountain as fixed. The trees survived an eruption, a pesticide-driven collapse of their only pollinator, 2 failed insect reintroductions, and a taxonomic dispute that ran for a decade before anyone had the material needed to settle it. Whatever comes next will likely take longer than anyone currently planning it expects and turn out, in the end, to matter more than anyone currently planning it can predict. The 3 trees Arata found in the spring of 1987 are still there. If a species can come back from 3 trees on a volcanic rock shelf, it's worth asking what else out there hasn't been given the chance yet. Subscribe if you want to see the next one we find.